Good evening, all. Let's wait for a few more minutes so that other participants can join the session. So it's time already. Without any delay, let's get into the session.
Okay. Yeah, maybe with the permission of Balaji sir and the team, can I start? I would like to introduce. It's like
Sir, good evening. Good evening, sir.
yeah.
Excuse me.
Good evening,
I request
Balaji
our
sir.
coordinator, Dr. N. Balaji, sir, introduce our resource person, Mr. Ravi Kulkarni, sir.
Yes. Good evening to one and all present over here. It's my pleasure to welcome Mr. Ravi Kulkarni, sir. He is a DevOps engineer, architect, consultant, and technical trainer with over 14 years of experience in DevOps, cloud computing, and automation in Pune. He has worked with the top IT industry like Wipro, UBS, and Cognizant, specializing in CI, CD, and IAC, DevOps, security operations, and cloud migrations. As a corporate trainer, he has delivered customized DevOps and cloud training for major organizations across India and Gulf. He is also an active mentor and contributor on GitHub and Stack Overflow, helping professionals to enhance their skills in DevOps and open source tools. I welcome you, sir. I would like
Yeah.
to hand over the session.
Thanks, Balaji sir. Yeah.
I would like to hand over the session to you, sir. Thank you, sir. Once again, I welcome you, all the participants, to join the day 2 session. Thank you.
Right. Thank you, Balaji sir, for that quick and very great introduction of me. Okay. Okay, so let me just add a few more things with respect to that. Okay, so I am apart from my technical background and all. Okay, uh, I've been in the industry for around 14 years, and then I left my full-time job and become a technical trainer and consultant. My voice is not good today, bit issue with my sore throat, but I believe you are able to hear me clearly and you are able to see me properly. If you can just confirm on that in the chat,
Yeah,
Yes, sir.
sir.
please.
Yes,
Yeah,
sir.
yeah.
Yep, sure. Thank you. So, apart from this technical things, why I've chosen to be a consultant and why I've chosen to be a trainer, technical trainer, is because about my passion towards mentoring the people. So, over the period of time, I found that people were struggling with different technologies, and as you see, the industry is evolving very fast in terms of the technology, in terms of the new tools and software, so on and so forth. Okay, so eventually I found it like, okay, how to learn a particular software. Okay, rather than being concentrating on one software and then next of software is coming in another year or so. Okay, how to concentrate, how to learn a particular software. Out of that, okay, I got into this training and consulting area. So yes, I'll be covering today's topic is container orchestration using Kubernetes. Okay, so it will be a session. Let me share my screen quickly, and let me start without being further delay. Okay, so let me just show you that how the session is planned. Okay, how I'm planning to have this session. Okay, so first 30 minutes. Okay, first 30 minutes will be going through understanding of what is orchestration is, what is basically Kubernetes is, its component, architecture, and all and so those things. Okay, starting from a very basic level understanding to understanding the architectural level of Kubernetes. Then I'll have a rapid fire round with you where I'll be asking the questions in the chat and you have to answer me with the one word answer. Okay. And of course, there will be a question answer sessions. Okay. After 30 minutes. Then after that, what we will have is whatever we have learned, okay, we'll be able to see that using the hands-on demos. Okay. So considering the time limits and all, I'm not sure I'll be able to guide you with the demos that how hands-on is done, but for sure I'll be able to show you the demos with respect to the Kubernetes. Let's say a simple Nginx application, how to deploy it and how to expose it so that we will be able to access that application. Then after that demo, we'll be again going through some of the features like scaling is there, replica sets are there, then how to deploy and roll back the applications into Kubernetes, and then we'll should see that demo also. Okay. Again, after that, we'll be covering about 5 to 10 minutes use cases. Okay, where exactly we should use Kubernetes and where we should not. That is also a very important thing that we are going to cover in 5 to 10 minutes. And last 5 to 10 minutes, we'll giving it to the question answer sessions. Okay. Does that make sense? Is it good? Is it okay? If you feel that is okay, put yes in the chat. Please put yes in the chat. If that makes sense to you. Okay. Thank you. Oh yeah, thumbs up also you can give it. No problem on that. Okay. So I think Sir has given my introduction, but yeah, this is what uh, uh, my small introduction again. So I'm basically a Google certified DevOps professional. Along with that, I'm GitLab certified also, and I'm Jenkins certified also. Okay, I've covered lots and lots of batches with respect to the IT companies, the lateral batches, the pressure batches, and these are my areas of expertise: AWS, GCP, DevOps toolchain, container technologies, CI/CD, configuration management, infrastructure as a code, and agile. Okay. Now, starting with point number one, that when it comes to the orchestration, okay, when it comes to the orchestration, what basically is orchestration? Okay, what is okay? Leave about container orchestration. What is orchestration? Okay, have you seen any orchestra? Maybe you would have seen that on the YouTube or maybe in the live. Okay, so in the same way, right? So what is orchestra? That there are group of musicians. Okay, let's say that there is one musician with the guitarist, one musician group is with the piano, one musician group is with the flute, right? So there are, let's say, three musician groups are there, and in that orchestra there is one person with the two state who is trying to guide them. Okay, with what kind of notes they should use or what kind of music they should create, so that a sync is created between these three groups of music, and then a proper music is heard. Okay, an orchestra is created. The same concept we are going to use for the containers. Okay, how many of you have idea about container? What is container? Can you give me here? Can you give me what is container in one line? One line. What is container? Anyone in the chat? Huh? In the chat, give me what is container. As simple as that. Medium of storage, area where the code is isolated and running. A small computing unit, software package, collection of framework, lightweight portable unit for a yes. Okay. So yeah. So if I put it okay in a way that what is container? Basically, it is an portable unit of software which can be deployed across any location, right? Maybe it's on-premises servers, maybe it's a cloud, maybe it's any other orchestrator Kubernetes or anything like that. Okay. So container is packed with all the required softwares which are required to run the application, the application package, and all the required networking part. Everything is there inside that container. Okay. Now that container, what we do is we create the image, and then that image, when we run that or when we execute that image, it becomes a container, right? So container has everything to run our application, as simple as that. Okay. So let's understand that quickly, that why we thought of having a orchestration. Okay. So but before that, okay, we will understand about containers and containerization. So basically, containers are nothing but packages which has all the required application, its dependencies into single unit. What is the advantage? Portability, consistency, scalability, and isolation. Now I read very good English words, right? Portability. Portability means yes, I can take that image as simple as that. I can take any file and I can put it somewhere. I can run it with some software like Docker or something. Yes, portability is there. Okay. If you consider the virtual machines are there, they are not that portable, right? It is not easy to take the virtual machine and put it somewhere. Then we have consistency, right? Consistency. Deploy it on Windows, deploy it on Linux, deploy it on Mac. You deploy it on any environment. Okay. Because nothing is dependent outside of that container. Okay. There is a consistency in terms of running the code. So code will be executed as it is because there is no external dependency to my container. Everything is packed inside the container. That's why, right? Scalability. Now that is also one of the important advantage, right? So I have my image. I can create multiple containers out of it. So I can easily scale up and easily scale down, which makes that an advantage that whenever I need more application instances, I can create that, and whenever I need less, I can also reduce it. So that is how scalability is measured. Isolation, yes. As I said, like everything is packed inside the container, it is isolated. Okay. Now, key technologies are Docker and container. Now, these are the technologies, or these are, I would put it, the applications through which you can create the images, you can create the containers. Okay. Now, we understood about containers. Now, we are going to understand about how containerization happened over the period of time. Okay. Let me just 1 minute. Allow me 1 minute, please. Yeah, thanks. So, yeah. So, how containerization came into the picture? Okay. So, initially, the traditional deployments looks like this. So, I have a simple hardware. On the top of it, I am installing some operating system, maybe Windows, Linux, Mac, anything. And then on top of it, I'm deploying my applications. In this traditional deployment, what is happening is I'm just concentrating on my particular hardware. Okay, I cannot use it for another purpose. Okay, so that is dedicated to a particular application only. Okay. Then came the virtualization deployment, where we thought of virtualizing the hardware in in the sense that can I virtually create two different CPUs, two different RAM, okay, with one hardware. Okay. So that is what the virtualization is. Virtualization means you are having single hardware and you are sharing that hardware and creating the multiple resources out of it. Okay. So hypervisor was the software which helped us to create a virtualization in hardware, and using that we were able to create a virtual machines like this. Okay. Now a single virtual machine can act as a plain instance similar to what we had in the traditional deployment. So using the same hardware, using the same operating system, but installing the hypervisor as a software, we can share or we can divide the resources, that is CPU and RAM, okay, and disk also, and we can create a different virtual machines out of it. Okay. Now there was an issue. Now what was the issue with this? We are happy that okay, we are able to use make a maximum use of our hardware. But let's say that if this VM goes down, what happens? That again I have to create my virtual machine, again I have to assign RAM, CPU and other resources, and then again I have to build it. Okay, which was again a tedious process. In terms of the scaling, let's assume that I have virtual these both the virtual machines are down, okay, went down. What happens? It will take me around 2 days to 3 days to make my virtual machine up and running with the application. So that's why they thought of virtualizing the operating system. They thought of virtualizing the operating system. And that is where container deployment came into the picture, or that is where containerization came into the picture. So rather than hardware, I'm keeping my hardware as it is. What I'm going to do is I'm going to use my operating system through which I'm going to create a small container like structure which are capable of serving the application using a container software like Docker and containerd. Okay, so there is something called as container runtime. So we have a Docker runtime and all using which we can create a containers. Okay, these are the lightweight portable units which can be easily created and deleted. Okay, without any issues. Okay, and those are really scalable because a particular container unit can take up to maybe 2 seconds to 30 seconds or maybe 2 minutes. Okay, to get up and running, rather than the virtual machines are taking 2 to 3 hours. So that is what we reduce the time. Okay, we were able to scale the things very easily. Okay, any doubts in this? Are we good? Are we good on container and containerization? Yeah. So I done that. I did. Okay. If you are able to understand the concept, do let me know. Right. Good. Okay. Moving ahead with the next. Okay. Now that is where the challenges came. Right? Challenge came. Okay. Now think about it that I have 100 rupees note and I have 100 rupees. I have a 1 rupees coin, which are 100. Okay. So 100, 1 rupees coin and 100 rupees note. Okay. Which is manageable. 100 rupees note is manageable. But if I go ahead and if I know I really want coins, okay, I want to play some game and there's 1 rupee coin is required to play that game every time. So what I'm doing is instead of having that 100 rupee note, what I'm going to have is 1 rupee coins, 100 in number. So that is how. But managing that is not easy, right? In the same way, if I try to create a containers, I can create 50, 100,000 containers at a time on a machine, but managing those containers is bit difficult, or I would say it is not that bit difficult, it is very unmanageable. Okay. Now, reason being complexity. You have to manage the dependencies, you have to manage the configuration, you have to manage the multiple containers. Okay. Let us take a simple example again. Let me add a page over here. Okay. Let us take a simple example. So I have my Airtel website. Okay. And in that, I have a postpaid service. I have a prepaid service. I have, let's say, a landline service, and I have, let's say, a payment service. Okay, Airtel Pay is there. Okay, so let me just show you quickly. Okay, let us see that. Let us see this. So Airtel.com. Let's say that I'm managing Airtel.com for India, and I have these many services are there. Right? Prepaid is there, postpaid is there, Wi-Fi is there, DTH there, bank is there, Airtel Finance is there. Okay. So I've taken only four services. Okay. And now what I want is, okay, for all the four services, I have created a container. So let's say container one, this is container two, this is container three, and this is container four, right? So now assume, let's say somebody want to take a postpaid service. Somebody want to take a postpaid service. So they applied for postpaid service. So they have to pay for something, some amount, XYZ amount. So postpaid service have to communicate with the payment. Let's say C4. Yes. Now somebody want to convert a prepaid to postpaid, right? So I have my prepaid account is there, and I want to convert that to the postpaid account. So again, C2 should interact with C1. Okay. So I can have my solution can have C1, C2, C3, C4. Okay. And there are, let's say, for each, there are 10 containers. Okay. So for one service, for C1, there are 10 containers. For C2, there are 10 containers, and so on and so forth. Okay, sorry, 10 containers. So accordingly, for C1, C2, C3, I will have 40 containers. Okay, so 10 instances. So if I'm saying 10 container means there are 10 instances for C1, C2, C3, and C4. Okay, now you want to communicate between these 40 instances, or you want to communicate between these 40 services, I would put it, right? So it becomes very difficult to manage. Yes or no? You are able to understand, right? Now we need some kind of orchestrator for that. Now that is where the word comes, orchestrator. Okay, just like as I gave you example of orchestra, three groups of musics, flute is there, guitar is there, piano is there. There should be one person who should govern them with a proper music notes, so that a sync of the music should come from that three groups. In the same way, now I have my application which are different, which have the different services, and those services are interdependent on each other. Now to have a proper communication, to have a proper coordination, okay, I need one software who should be able to manage these complete services. Yes or no? Do you agree on this? Right? So now what I'm going to do is I'm going to mention that over here. Right? So that is where container orchestration comes into the picture. Getting it? Okay. So why it is required? For the deployment part, for the management part, for the scaling part, for the networking part. Now you think about it. Such a website is there. There are so many services are there which are interacting with each other. So I need a software which should be able to handle all these things, right? Particularly in terms of the deployment. Let's say I want to deploy a particular service. I want to install a particular service. Okay, we should be able to do that. Managing it. Now managing means, let's say 40 containers are there. Let's say one container goes down. Okay. How would I know that? Okay. And every time I'm not going to say that, okay, this container is down. Okay, I'm going to manage it. Okay. The whole 7 days I'm going to spend on that if I do it manually. So I need a software which will auto heal or which will auto correct my container with that given point of the time. Okay. Now let's say that if there's a requirement, a e-commerce website requirement is there, Diwali is coming or festivals are coming. Okay. My software should be able to easily scale up at that point. My software should be easily scaled down after my festival is done. Let's take an example of train booking, IRCTC. If you have done that, right? So between 10 to 12, we have a Tatkal booking. So in that case, IRCTC should be able to scale their application like anything. And after 12 o'clock, they should be scaled down. So how it is going to happen? Okay, we need such kind of proper solution for this, right? So that is where container orchestration comes into the picture. So it helps in resource utilization, it helps in scalability and high availability, and it creates a simplified management through which we can see that thing, and yes, it is easily managed. Now these are the popular container orchestration tools: Kubernetes, Docker, Swarm, Apache Mesos. Okay, one of the important tool is Kubernetes. One of the important application is Kubernetes. Okay, so now we are going to start with the Kubernetes. Now you are able to understand, right, from that point, from where containers, how containers are created. Okay, what was the need of the container? Okay, when we go from one container to 100 to 1000 containers, what is the need of orchestrator? How orchestrator can help us with management, deployment, and scaling. And now that is the open source software, which is Kubernetes, which is one of the orchestrator for container. That is what we are going to now. Okay, so Kubernetes is an open source platform, which means you can go ahead to the Kubernetes platform, you can take the code of the Kubernetes, you can build your own Kubernetes, and you can use that. You can take that Kubernetes as it is and you can deploy it without any licensing cost. That means it is free of cost. It is developed by Google, okay, and then donated to CNCF, Cloud Native Computing Foundation. Okay, so what is Cloud Native Computing Foundation? Is again a open source foundation, okay, which focus on the cloud native tools and applications. If you know about it, I'm not sure. CNCF, there are hundreds and hundreds of projects with respect to that. So if you go to the CNCF over here, okay, so it is focusing on the cloud native. That means whatever the applications that are deployed in the cloud. So these are the projects. Okay, the one which are graduated means you can use it. The one which are incubating means those are in the development phase. Okay, so if I click on the graduated projects, you will be able to see Argo CD is there, Cilium, this cloud event is there, QFS type. So there are different types of projects are there. Helm is there. So tomorrow we are going to learn about Helm. Helm is again a CNCF project. Now the interesting fact about Kubernetes. So Kubernetes was developed by Google, but when it was developed in 2004 only. Okay, by Google. It was developed in 2004. So you can, and it was given to CNCF in 2016. Okay, so around 12 years, Google have used it. Okay, Kubernetes, and then they have donated it to the open source. And 2016 onwards, people started using it. I mean, the public started using the Kubernetes. Now, think about it. Okay, if the Google has developed such kind of thing at that point in 2004 itself, okay, think about it. Google is at what position now? Okay, when we saying we are just starting with the AI. So that is a very interesting fact that 2004 Google did it and then it donated in 2016. So till that point, we were not aware of it. Okay, key concept. Now this is very, very important key concept of Kubernetes. The first thing is cluster. Now, when I'm saying about a cluster, okay, what is cluster? It's a collection of nodes. Okay, so let's see that. Okay, so this is how your Kubernetes is. So it is a collection of nodes. Node 1, node 2, control plane is also a node. Okay, then we have nodes. Okay, so inside the cluster, this complete diagram is a cluster. This complete diagram is a cluster. Now, if I go ahead with the pods, okay, so what is pod? Pod is the smallest deployable unit. Now, as you see here, okay, this is the pod. Let me put that this way. Can I? Yeah, right. So this is the pod. Now, what is pod? A smallest deployable unit. So inside the Kubernetes, if you want to deploy the application, we create the pod and then we deploy the container inside that. Okay. What we do is we create a pod. We'll see that. Don't worry about it. Okay. So your application is deployed under the pod. This is the cluster. These are the nodes, node 1, node 2, node 3, node 4, as per your choice, whatever you want to do it. And this is the control plane. I mean, this is another node or the admin node. You can put it. Okay. Then we have a replication controller or replica sets. Okay. Now, we'll take this in a minute, but let's move on with the next thing. Deployment services, config map, secret namespaces, ingress. Okay. Let me just cover this first to you. Okay. The architecture part. Okay. So as simple as that, you have this cluster, and in the cluster, you have the nodes. Okay. And in the node, you deploy the pod. Till this point, it looks very super. I mean, it looks very easy. But oh, I see there is something called as etcd is there, scheduler is there, kube API is there, controller manager is there, kubelet, kube proxy. Some all these words are there. Okay, there are different parts are there. So what we call them as, these are the components of Kubernetes cluster. These are components of Kubernetes cluster. So I have a control plane. Okay, so which we call it as a administrator plane, or which we call it as a admin node, which is called as admin node. So in the admin node, we have first called kube API server. Now what is API server? API means it is going to take the request. Whatever you are going to send it to the Kubernetes, okay, it is going to take that request, okay, as a first counterpart. Okay, let me draw it for you quickly. Let me open the print. Right. So as simple as that. Okay. So this becomes my cluster. Okay. This becomes my control plane. Let me put that with the green. And the first part of my control plane is my API server. Okay. Let's take it this way. So let me put, this is my Kubernetes. This is my cluster. Or let me put Kubernetes cluster. Okay. This is, I can say it is my control plane or my admin node or master node. I'll put it in very simple words. This is my admin node, or we can call it as a control plane. And this is my API server. This is my API. Now, let's assume that you have a laptop, right? This is your laptop, and now you want to communicate with your Kubernetes, right? This is your laptop. Assume that this is your laptop, and then you want to communicate with your Kubernetes. How you are going to do that? Okay. So first of all, the interaction will be the API server. Okay. So the first interaction will be the API server, right? So you are, let's say that you are writing some code over here, and you are going to send that code to the API server first. Okay. So the first encounter with the Kubernetes cluster will be API. Okay. Then we'll have a key value pair node, which is called as HCD, or in other words, this is called etcd. So etcd is nothing but a database, okay, which store all the transaction with respect to Kubernetes. They store all the transaction with respect to the Kubernetes, okay. And the API will send the details to HCD saying that, okay, this is what I have got it. Okay, please register this, whatever request I have got. Let's take a simple example that create. So request is create three. Let's say name of the application is Eagle. Three Eagle instances. Okay, and all the details are already given. Okay, a YAML file is sent, and that YAML file has all the details with respect to what needs to be created with respect to the Eagle instance, one and so forth. Okay, we will see that. Don't worry about it. Okay, so the request is create three Eagle instances. Eagle is an application. So it is going to go to the API. API is going to send to the HCD. Okay, do register that we have to create the three Eagle instances. HCD will register that, all those things. And then it is going to send the request back to the API saying that please schedule the instances on nodes. Please schedule the instances on the node. So for that scheduling, we have scheduler. We have scheduler. Okay, we have scheduler. So API now will take this request. Okay, will go ahead and send to the scheduler, and then scheduler is going to schedule. Scheduler is going to schedule the pod for the application. Okay, on the node. Let's say node 1, and then another node I'm going to draw it. Let's say node 2. Now it is the choice of the scheduler, because I have given three instances. Where to create those three instances, it is again the choice of the scheduler. So scheduler is going to decide whether I should create that on the node 1 or node 2, or combinedly on the node 1 or node 2, or combinedly on the node 1 and node 2. So this is my node 1, this is my node 2. Assume that scheduler schedules the instances, two instances, or the pods, two pods on node 1 and one pod on the node 2. Now this is the choice of the scheduler. Okay, so now I'm happy. My pods are created, my applications are running inside it. Let's say A application. I'm going to name that application as A application is there. I'm happy with that. Everything looks good. But what if what if my application goes down? Let's say this application goes down. What is going to happen? Let's say this application goes down. What is going to happen? So I need some kind of a controller manager. What I need, I need some kind of a controller manager. That is the next component in the Kubernetes, controller manager. Okay, which is going to check the status every time. Okay, whether those three, what is the condition given? Three instances of eagle should be there. So it is taking one is there, okay. Second is there, okay, but third is not there. So there is an issue with the third. So what is going to do? What controller manager is going to do? It is going to send the request to the API. API is going to again register that thing, that HCD, that one instance is one instance has failed. HCD is going to again ask scheduler saying that please create okay another instance, and scheduler is going to create another instance maybe over here. So new instance will be created automatically and the old one will be deleted. Old one will be deleted, right? So old one will be deleted automatically. You don't have to worry about it. Okay, and controller manager will make sure that okay, now I have proper third instance running with properly with the A application. Do you got this? Are we good on this? Do you got the flow of the application, that how the things are moving in the Kubernetes, right? So this is how the Kubernetes is, right? So API is always going to take a request, whether it is from the user, whether it is from the HCD, whether it is from the scheduler, whether it is from the controller. Okay, so API is going to work with all the people, right? Now, there is one more thing to it, right? So one more thing to it is now scheduler is going to schedule it, but who is going to actually going to create it? It is someone over here. There is someone over here, okay, who is going to follow the scheduler orders. Now, who is that? That is kubelet. That is kubelet. So now kubelet is the one who is going to create a pod. Okay, let me just put it over here. Scheduler will only schedule the things, but kubelet is going to actually create it, right? So it is like a boss is ordering, okay, I need a pod to be created, and then kubelet is like a servant. Yes, sir, I'm going to create a actually pod. So it's going to work. In the same way, I have drawn this diagram. Are you able to get this now? So I have my Kube API server, okay, who is the single point of contact for everyone: HCD, scheduler, controller manager, end user, node 1, node 2. Okay, so this is a kubelet who is going to create a pod, and inside the pod, containers of the application will be created. Okay, yes. So yeah, any questions, please? Use of the pod. Okay, so now that is okay. So pod, you can think about it is a logical environment, okay, created to create the container inside it. Okay, so it is just like you can say that let's take example of virus. Okay, so in the outside environment, okay, outside the human body, virus has, yeah, I understand that there are questions. Okay, I'm going to give 5-10 minutes, right? But allow me a minute. Okay, I'm just going to answer Saranya's one. Okay, and then we'll have 5-10 minutes. Don't worry about it. Okay. So pod, you can think it as simple as that. Let's say that I have a virus. Okay, so virus you can consider it as a container. Okay, so virus is completely dead outside the human body or in the environment. Virus don't do anything. But when you put that virus inside the human body, what happens? COVID happens. Okay, or virus becomes active. Okay, so that means that that container requires an environment. Okay, so Kubernetes creates a logical environment, or we call them as the smallest deployable unit. Okay, inside which you can have a container and then container will start running. Okay, all the required resources with respect to CPU, with respect to memory, RAM, and all those things, disk and all, can be assigned to a pod. And that pod creates a logical environment inside that the containers can be executed. Okay, getting it? Container is not a pod. Container contains an application. So I'll put it in this way. Okay, let me put this in this way. So this is my pod. Let me divide. Let me put that. Or let me draw it over here. Okay, separately. So this is my pod. Let me put the pod over here. Okay, and inside the pod, I have my containers. Okay, maybe a group of containers or a single containers also. Okay, like this, I can have different containers. Okay, and pod serves as a single unit. Pod serves as a single unit of application. Okay, pod serves as a single unit of application. Got it? So you can have containers, and then inside the containers, there is an application running. Okay, or maybe I'll put it like this. So this is my different application. Maybe I'll color it with yellow and one with blue, one with blue. Right? So are we good on this on the pod? So this is how the pod is. But at the Kubernetes level, okay, you cannot differentiate between the container. Okay, if the pod is down, your application is down. So a new pod will be created automatically. Okay, so there is a pod life cycle also. Pod contains the containers. Yes, inside a container we have a data sets. No, I won't say that it has a data sets. Okay, but I would put it has applications. Okay, data sets are more on the persistent storage. Okay, probably you will have a session tomorrow on that. So there is a separate topic with respect to how the data is stored in the Kubernetes. So we call them as a persistent storage. Okay. If the node fails, uh, if the node fails, everything fails. Okay. So particularly in the AWS, so that's why they came up with the managed solutions, which is called as AKS. So in the AKS, that node failure is also considered. Okay, so there is called as Elastic Kubernetes Service. In the Elastic Kubernetes Service, you can create a cluster, and AWS will take care of it. Okay, but when it comes to the on-premises, mostly it is your similar to the VM in the traditional system. Yes, you can say that. Yes, of course, you can say that, but much more powerful than VM. Okay, much more powerful than VM. Okay, so if the node fails, everything fails. But then we have something called as managed Kubernetes solutions through which you can also manage your nodes also. Okay, just like AWS is there, Azure is there, GCP is there. These are the clouds which provides you managing the nodes also. Okay, now this is a typical standard CNCF diagram of Kubernetes. Okay, so we have again the Kube API server, scheduler is the controller manager is there, HCD is there. Uh, just like this is on premises, we have for the cloud, there is a separate cloud controller manager through which you'll be able to manage your cloud nodes. Okay, if you have a hybrid structure like on premises and cloud, so you will be able to manage those things. Okay. Yes. So now we will now understand about the key concepts. Cluster, we understood it. So cluster is overall complete foundation of Kubernetes where we have all the nodes. Nodes are nothing but individual machines or the virtual machines. I would put it as simple as that. Okay, where here all the things are installed. So can we create a pod within the pod? Yes, there are capabilities now, but I think those are in uh, what do you say in the development phase. Okay, so standard way is to have a pod, and inside that we put the containers. Okay. Yes, replica controllers or replica sets. So now we have replica controllers. That means let me show my diagram over here. Now, as I said, like three eagle instances. So in that case, what is happening is three eagle instances means okay, it is going to create a three replicas of an eagle instance. That means three pods. Okay, so controller manager is going to make sure that at any given point of the time there are three instances, but there is a software who is working behind it, making sure that there are three instances at any given point of the time, and that is called as replica controller. Replica controller. Okay. Yeah, so it ensures that specific number of pods replicas are running at any given point at the time. And replica set means how many sets you want it for that particular application, or how many pods you want it for a particular application. That is nothing but a replica set. So replica set, you define it. Let's say I want four replicas. That means four instances will be created. If you want five replicas, that means five replicas will be created. Okay. Now let's go ahead and let's understand it through the some demos. Okay. Are we good till this point? Let me start it. Let me restart it. So this is basically a platform. Okay. Killer Coda. Okay. So people can also use it. Maybe you can also use it. Okay, I'm just posting that in the chat. Maybe once you have a good time or free time, you can just use it. Very good platform. You can just simply spin up the Kubernetes over here. Don't have to work on that, okay, how to install and all those things are there. Right? You can go ahead and you can simply go ahead and you can start it. Okay. So now this is my control plane. Okay. Control plane means master node. Okay. So let me just check it. Now to start with, we need to have a kubectl. Okay. So kubectl is a tool. You can simply go ahead and you can install it. And using that kubectl tool, you can interact with the Kubernetes. Okay. Now, only directly by just installing kubectl, you cannot directly do it. But for that, you need to have a .config file under .kube folder. So this, if you see .kube folder over here, right? So you need to have a .kube folder. In the .kube folder, you will have a config file. This config file defines all the details with respect to your Kubernetes cluster. That means which is the user, okay, what is the server, where exactly your Kubernetes is installed, so on and so forth. Where it is kept, remember that it is kept under the .kube folder config file. .kube folder means it is under your user account. Okay, let me just show it to you. PWD. So this is under your user. Now I'm using the root as a user. So under the root user, okay, a home folder, I'll have cd under that .kube, and under that I'll have my config file. Sorry. ls, and this config file is there. Okay, so under the user folder, you can create a .kube folder and you can get the config file from the Kubernetes. Okay, you will be able to see that. Don't worry about it. Okay, now let's go ahead and let's do this. Something which is, so here what I'm going to do is, let me just show you something. Kubectl get nodes. Okay, so using the kubectl you can get the nodes, pods and all. So kubectl get nodes, so I'm able to see that. Okay, there is one control panel and there is one node, so it is two node cluster, or maybe you can call it as a one node cluster of Kubernetes. Okay, or maybe you can say this is the working node where your pods will be deployed, and this is your control plane. So on the control plane you will have all your components. So kubectl get pods. If you do that, then hyphen n cube system, oh, sorry, kubectl get spaces cube hyphen system, my bad, huh? Cube hyphen system. So you will be able to see, okay, you will be able to see if you get the pods hyphen and kubectl. If you do this, you'll be able to see there are HCD, there's a API server. So all the pods are also created for those components. Kube proxy is there, scheduler is there, right? So all the control plane pods or all the control plane components are also created as a pod only. Okay. Before going ahead, there is a concept called namespace. Okay. Now we have smallest deployable unit as pod. But what if I want to have, if I have a finance department, if I have admin department, if I have a IT department, if I have business department, four departments are there, and they want to work in a single cluster. How I'm going to do that? So there is a concept called namespaces. Okay, so what we do is we create a namespace. So kubectl create namespace. Oh, sorry, namespace, and you can just put namespace also like this. Okay, and let's say demo. Okay, so namespace is created. Now what you can do with the namespace, you can assign the memory, you can assign the CPU, you can assign the disk to this particular namespace. You can store the particular secrets in this namespace, username, password, anything with respect to the application. Okay, so it is like having a flat system. Okay, so you have a land and then you create a flat out of it. So there are hundreds of flats, but every flat is isolated with each other, right? So every flat has a different family, okay, staying inside it. So namespace in the Kubernetes cluster is like that. Okay, so you can create a namespace, and in that namespace you can create your own. Getting it? Okay. Scalability, maybe yes. Okay, but you have to define that. Okay, scalability means you have to define the range. Let's say that I want to have 2 to 10, like that, with respect to your replica set. So you can have two replica set and maximum 10 replica set, and accordingly it will move it based on the requirement. Okay, so okay, now this is created. Let me just go over here just a minute. Now let us see that how you can deploy the application. Okay, pretty simple commands. I'm going to create it. I'm not going to go much more into the details. Pretty simple commands, right? So I'm going to deploy the Nginx over here. What I'm going to do is as simple as Nginx is a simple web server, which I'm going to deploy. Now, when you are deploying in the Kubernetes, there are two steps to it. There are two steps to it. First, you have to deploy the application. Second, you have to open or expose that application to the internet. You have to expose that application to the internet, outside world. Okay. So now I have deployed Nginx. Now you see, as simple as that, my application is deployed. Pretty simple, right? So if I say kubectl get deployment nginx -app application is working. So my 2 of 2 Nginx application is working. Okay. Now I want to expose it to the outside world. For that, I need to have a service. Okay. I need to have a service created for it. Okay. So what is service? Service is nothing but a logical name given to your deployment or to your application in short, okay, which will be identified by outside world. Okay, just like we have our pet word, okay, which is inside our home, and the official name which is outside our home, right? Like Chunnu Munnu, we call it in our Kuti and all those things. We call it when we are at home, okay? But official name, you can have it outside the world as standard names like Ravi, uh, then Renuka, and so on and so forth, right? In the same way. Here, using this service concept, what we are going to do is we are going to expose this to the outside world. So I'm going to expose it using the Kubernetes. So my service name is also I have given as Nginx app. Okay. Now I have given this. So I'm going to go ahead and I'm going to check that where exactly it is exposed. Okay. Don't worry about commands. We are going to work on the commands also. But quickly, let me just show it to you. Okay, so let me describe it. So here, as you can see, my service is exposed on the port number 32588. Okay, 32588, right? So now I'm going to go ahead and I'm going to open that Nginx over here, right? So let me go ahead with the host 2 with 32588. Okay, on the host 2, basically 32588. Now, there are different ways of also exposing the services. So we have exposed it to the port number 32588. Because we have not given any port number, it has taken this random port number for us. Okay. So 32588. And if I access it, I'll be able to see welcome to Nginx. Okay. Welcome to Nginx. Okay. So yes. Now I'm open to 5 minutes. Let's take a 5 minutes question answer session. So till this point, I believe now you have got it, right? So what is Kubernetes? What is orchestration? What is Kubernetes? Then what is how we can deploy the application? First you have to deploy it, then you have to open it to the world. That means you have to add the services. And then there are components or the architecture with the Kubernetes. So if you have any questions with respect to that, do let me know. Or let me just take it one by one over here. By default, how many replicas are created? No replicas are created if you don't define the replicas. Okay, Lavanya is saying about Kubernetes versus Docker. Okay, Kubernetes versus Docker. So Docker is a container management tool. Docker is a container management tool. That means you can have a life cycle of the container managed by the Docker. That means you can create the images, you can install or create the containers, so on and so forth. Okay, and Kubernetes is about, let's say that you have multiple containers to manage. Docker cannot manage multiple containers. Docker cannot network between, let's say, a postpaid and prepaid services are there deployed on the two containers. Docker cannot manage that. Okay. Docker cannot auto heal. That means, let's say one container is down. Okay, goes down. Docker cannot recreate that. Okay. There is no check by the Docker that this container is up and running or okay. Kubernetes is the one which will help you with the Docker with the auto healing, with the scaling. Docker cannot scale it. Okay, using like replica sets or something. Okay, Docker don't have that feature. Kubernetes have that feature that if you define the replica set, it is going to. Okay. Yes. Okay, I'll explain that, Kiran sir. But before that, let's okay, sir. Microservices. Yeah, 1 minute. Microservices explanation, creation, related containers. Microservices. Okay, microservices is nothing but, let's say that you have a monolithic service. I have a simple diagram to it. Microservices design pattern. Services. No, not like this. Okay. So in short, you understand it. Microservices is like you have a monolithic service. Okay. You have monolithic service and you break them into the microservices. Okay. Let's say 5 microservices, monolithic services there. And now you are connecting this. Okay. 1, 2, 3, 4, 5 with each other. Okay. Now, because it's a microservice, that means a single service. Okay. Solution is one monolithic application. I divided into microservices. Now I created one container out of it, another container out of it, third container out of it, fourth, fifth. And now I'm going to network this container. And these 5 services, I'm going to deploy it on the Kubernetes. So this is what the microservices are there. And that's why containers are used in the microservices. Okay. Got it? Durga Prasad sir. Any good tools for the microservices? Particularly in what terms? Okay, if you can define that, I'll be able to answer that. Okay, but Docker is the one. I think Containerid is the one, and Podman is the one. Okay, through which you can just create a very good container images and um, containers. Okay. Yes, Kiran sir, you please explain the steps after creating the namespace? Yeah. Okay, sure. I'll do that. Okay. But I need to go to board again. So I'll just take if I can answer some theoretical questions. Can a deployment be rolled back? Yes, deployment can be rolled back. Okay, as simple as that. You can just roll back or you can delete it. Okay, there are two options. You can just go ahead and you can delete that, and you can just roll back also. Okay. Um, Let me take some more. Docker software is on operating system, but when OS fails, what to do? Okay. Docker software is on operating system. That means it is completely dependent on the operating system. If OS fails, okay, that means the Docker is not going to work properly, and then you have to work on some other node. Okay, as simple as that. Docker Swarm and Kubernetes compared implementation wise. Docker Swarm is very good. Okay, I'll put it in. Again, I'm putting it, right? Docker Swarm is very good if number of services or microservices are less, if containers are less. Okay, management becomes very good. But when it comes to the scaling, when it comes to the high complexity microservices or solutioning, okay, Kubernetes is the right way to. Okay. Docker Swarm, if you are using Docker, pretty much compatible. And I simply suggest to the startups also, I suggest them that please go ahead with Docker Swarm first. Okay, if you don't have something big to offer, go ahead with Docker Swarm. Kubernetes is for a large scale applications, okay, where you are divided, let's say 10, 20 microservices, and then you are serving it. Okay. Can multiple containers from the different region be joined in the Kubernetes network? Can a multiple containers from the different regions? Now, particularly with the regions, if I say, I'm not sure, but yes, you can have multiple containers inside one pod. Okay, and that pod, okay, can be connected to another pods also in a different region. They can interact with each other based on the API server. So everything, every request, every communication is going to happen with that API server. Okay. So this way you can work, right? Yes. And if you add that node in the Kubernetes cluster, yes, even though you don't require API, you can directly then communicate with it. Pretty simple, right? Next question is, can you please share your GitHub ID so that we can take some notes regarding the Kubernetes? Okay. Standalone machine. Okay, I'm not sure that whether I'll be able to do it, but yeah, I'll give something through which you'll be able to do it step by step. Okay, don't worry about that. Can I multiple containers from the different regions? Okay, GitHub ID, I'll just going to put it. So it is cloud dev user. Okay, and this is basically Kubernetes demo. Okay, this is the repository. Okay, you can just follow this repository. There are lots and lots of things with respect to the examples and okay, which you will be able to do it. Okay, so yeah, so we'll take another 10-15 minutes to understand few more features, and then we'll go ahead again with the question answer sessions. Okay, I know I completely understand there are a lot of things with the Kubernetes, but yes, let me try to move ahead with the next thing. Okay, now there is something called as label and selector. Okay, Kiran Deshpande sir, I'll just come back to you. Okay, I understand that you want to understand after namespace what happens, that how deployment happens. But yeah, another 10 minutes, I'm going to push it for my PPTs. Okay, and then we will cover about the proper again with the deployment parts. Okay, we'll also understand about the replicas and all. Okay. So labels and selectors in Kubernetes. Okay. So labels and selectors are basically a key value pairs. Okay. In short, you understand it in this way. Let's say that there is a factory of clothes. Okay. So there are number of t-shirts which are created. Okay. Hundreds t-shirts which are created, and then we are putting the labels of different companies. Okay. Let's say one is Cotton King, one is XYZ, one is ABC. So 10 t-shirts for ABC label, 10 t-shirt for let's say XYZ t-shirts. So in the same way, okay, when you deploy the application, what you do is you create a label for that application, or you deploy the application with a particular label. So that is what the label is. So it is basically, a label is a key value pair through which the application is recognized. Oh, okay. And then let's say you want to update that application. So how you are going to update it? Based on the selector. So when you say select application with this XYZ label and get updated. So accordingly, it is going to have that application updated using select method. Okay. For example, selector is app equal to nginx matches all the pods that have label app equal to nginx. So while deploying, what we do is we deploy with the label, and while updating, while deleting or anything, what we do is we select it using a particular label. Okay. So now there are two types of labels. No, sorry, two types of selectors. Okay. With respect to that, you have equity base, that means app equal to nginx, and set base. Set means there are two or more. Okay, there are two or more labels attached to a particular thing. Let's say database container is there. So database, okay, for Eagle application. So DB equal to Eagle DB, and database type equal to Postgres, something like that. Okay. So accordingly, you can have selector app in Nginx and PHP that matches all the pods. So similarly, we have selectors. Okay, so labels and selectors are there. Okay, creating the pod and deployment using the YAML. So as simple as that, right? So as I told you, pod is the smallest unit. So what is there inside the pod? So it starts with the API version. Okay, so we have an API server for which we have to give the API version. Which API version you want to use it? So in the API version, in the API server, you have different API versions, V1, V2, okay, V1 apps, something like that. So there are different API versions. serving different types of request. Okay, kind. Okay, what kind of things you have to create? You want to create a pod, you want to create a deployment, you want to create a service, you want to create a service account, or what exactly? So that is, we are going to mention it over here. Then given that metadata means information about that, and then the specification that which container needs to be deployed. So this is the definition of pod, which you can go ahead and you can deploy it on your Kubernetes. Okay. Now this is a single pod. That means a single container is deployed. But when it comes to the deployment, okay, deployment itself has all those definition the pod, plus we have something called as replicas. We have something called as replicas. So here I have defined replicas as three. That means three instances of that application will be deployed. Okay. And then we don't define in the pod way, but we define in the template way. So what we are going to define it, okay, anything with respect to the deployment is created will follow this template. Template is app label, app equal to nginx is there. Specification I'm going to give them as containers. Okay. I've given you that GitHub repository. Everything is explained on that. There are good examples to it. You can just go ahead and you can run it on that. Okay, based on your time. Okay, so that is what the difference between a pod. Pod is single deployment, okay, or single container or single pod you are deploying it. Okay, it has no uh, any to and fro. But with respect to the deployment, okay, it's a proper set of applications or a set of single application which are going to deploy, which are going to deploy it. Okay, by defining the replicas. Okay, services. So as I told you, right? So once you do the deployment, your deployment is done. But now you want to expose it. So how you are going to expose it? There is a component called service. So what is services in Kubernetes? It's a resource which provides a load balancing within the Kubernetes cluster, network connectivity and load balancing within the container. Or I would say it is a logical name given to your deployment through which it can be it can be accessed from the outside world. Okay, so there are three types of services are there: cluster IP, node port, and load balancer. Okay, external name is there, but cluster IP, node port, and load balancers are the major one. So cluster IP means you don't want to expose your application outside the cluster. So what you do is you give the cluster IP, and that services or that application will reside inside the application. That can communicate inside the cluster, not outside the cluster. Node port. Node ports exposes the application or the pod to the outside world using a particular port on the node. Okay, so all the nodes, okay, so each node IP address with a specific port can access that application. Okay, third one is a load balancer. Pretty simple, right? So you define external load balancers. You create a load balancer. You attach it to your cluster, and then you define the name of the service with that load balancer service name. Okay, and then external name is basically you can map it with the some external DNS name. Okay, with the A type or C types of records. So this is what the service is. Okay, I completely understand. Yes. So the last one with respect to the replica sets and ruling updates. Okay. So somebody was saying about, okay, can we scale it up and scale down? Can we have rollback also? Yes, this is what the solution is, right? So you can define the replica sets. Okay. What basically replica sets is, it's ensure specific number of pods replicas are running at all the times. And rolling update means rolling updates, it is going to update your pods. Let's say that there are three pods which are existing, three pods are there. Now you want to update it with the new version. So what rolling update will do is it is going to put one pod down, update it, create another pod, then it is going to put another pod down, update it, and create another pod. Then it is going to put the third pod down, and it is going to create the third pod. That means it is going to have a rolling update. One, two, three, like this. One, two, three. Getting it? That is what the rolling update is. Okay. So now we will take quick examples of it. That you have your replica sets where replicas are defined over here, but in the rolling updates, you have your image. Okay, image definition updated in Unix version. That means this image. Let's say you are running 1.14.0 and now you want to update it to 1.19.10. So you are going to put 1.19.10. So it is going to do it one by one. One, two, three, like this. So one goes down, two are still up and running. Okay. Then one goes up, second goes down, then third goes up, the second goes up, third goes down, and then third goes up like this. Okay. So there is a zero downtime. Okay, when you do the rolling updates, right? So in short, that is what the Kubernetes is. This is just a tip of iceberg what I've given to you, but for sure I'll tell you that there are lots and lots of things, okay, which can be added to it. Okay, so Kiran sir, quickly to answer your question, and then I'll be open to the question answers in that. Okay, so now let me just clear it out. Okay. So we have a namespace, so kubectl get namespace, right? Kubectl. So this is my demo namespace is there. Okay, so namespace means you can define the resources CPU, memory, and disk to a particular namespace. Okay, what next we have done is um, we have we created a deployment. That means we deployed an Nginx app with the name Nginx app. I have given the image as Nginx. Okay, so latest Nginx image will be used. That is the Docker image, and replica is equal to 2. That means two instances of deployment will be created. So if I say 2 over here, so it is saying failed to create. That means it is already created. If I say 3 replicas, it is going to modify it. Okay, but we need to say kubectl update the deployment like this. We have to update the deployment, but let me not do that. Okay, let me just quickly clear this considering the time constraint, and let me delete it, the deployment, to show you again. Okay, so 3 replicas now. Okay, so I'm just going to create a deployment and kubectl get deployment in Unix -app. So here, sorry, my bad. Here I have 3 replicas of it, and then I'm going to expose this. Okay, already I have exposed it. Okay, the Nginx deployment is already exposed it. Okay, so to 80. Okay, so what I'm going to expose it with the node port type. That means I'm going to choose a node port for port 80. So port 80 is the Nginx port, which will be mapped with the node port given by the Kubernetes for the particular deployment. And using this node port, we'll be able to do that. Now, this is a different arrangement over here through which you can just go ahead. You can give that port like this, 328, and then click on access. So here you will be able to see the Nginx web application. So, sorry. So that is about it. So if you have any questions, do let me know. OpenShift is also, yes, OpenShift is also good.
Now mic is open to all. So if you have any questions, ask.
So I'm open to questions now. If you have any questions, do let me know. I completely understand. Okay, the topic is very vast. Okay, and few of the things maybe I would have missed out. Okay, but I tried my best to put all the things come together and at least give you the some knowledge with respect to the Kubernetes, right? Deploying the host and containers. Okay, let me just take these few things. The replica set is different from deployment. Yes, replica set is different from deployment. Yeah, so it is going to define the replica set is for defining how many replicas have. It is not going to create the pods. Deployment is the one which is going to create the pods. Okay, and replica set is a subset of deployment. Okay, just like for the tea, milk is important, but yes, you can have a tea without a milk also. Okay, so replica set is the same. That in the deployment, you put the replica set, and accordingly, Kubernetes will respond to you. Okay, so there is a difference between deployment, the host, and containers. Deploying the application on the host and containers. Yes, there is. So application is when you go ahead with the container, application is packed inside it, and then you take this container, you deploy it somewhere. But when it is a host, you have to first install all the OS, and then you have to install all the required dependencies, and then you have to install on the top of it the application, and then you will be able to run that application. The host will be dedicated to it. But containers, you install it, run it, delete it, again create it, and that's it. That's how it is. So I think it is 2:30, but with the permission, if I can explain it for one more minute, Balaji sir.
Yes.
Yes, sir.
Yeah. Okay. Um, yes. So how about efficiency when we use many macros into many parts and use it in the container? So Swarm, I really don't recommend it when it is like 20-25 services, microservices, or more than that. Okay. You go ahead with the Kubernetes, but if it is 5 to 10 microservices are there and you want to have maybe in the different regions also, Docker Swarm is really. Can you orchestrate VM with the Kubernetes? No. So VM is completely different concept. VM is based on hardware virtualization. Okay. Kubernetes is based on the OS virtualization. A container is basically the OS virtualization. So both are different concepts. So you cannot have a VM orchestration with the Kubernetes. Kubernetes is dedicated to the what do you say to the containers only. Okay, so it is like you have a golf and a cricket. So cricket is completely different genre, and golf is, even though they are played with the ball and stick, but both are different games. Okay, right. So I think I'll give overview of today's session in 3 minutes. Okay, and can we run KS8 on low config system? Yes, there are tools like Kind. Okay, you can just go ahead and you can just Kind, using which you can run Kubernetes on containers. Okay, on Docker. Okay, Kind is a tool. Minikube, yeah, Minikube is good, but then Kind is there, Customize is there, Customize is also there. Okay, so simply you can just go ahead with these tools. Pretty simple to have practice and all, right? Guidance on certification. So there are a lot of questions. Okay, probably tomorrow I'll be there with the Helm also, so I'll be able to answer these questions also. Okay, certifications also, I'll just keep that. Okay, so yeah, that is pretty much. I think if you have any questions, you follow it, or you can share it with the dean sir or with the ma'am. Okay, and they can mail me. I'll try to respond it through the email. Will that work? Yeah. So, okay. So that is pretty much from my side. Yeah. So you can email your questions to madam and sir. Okay. They'll share it with me and respond to all the questions. Don't worry about that. Okay. Thanks all then.
Okay, sir. Okay.
Yep.
Thank you, sir. Thank you for your informative and engaging session. And we appreciate at the time you took, you share your knowledge with us, sir. Thank
Yep.
you.
Thank you. Thank you all then. Have a good day.
Thank you, sir. Thank you
Thank
so
you.
much. Sir.
Really
Thanks for your
appreciate you
detail.
this opportunity to share my knowledge. Okay, I'll be happy, more happy to share such sessions or having such sessions in the future also.
Thank you. Thank you
Yep.
so much, sir.
Thank you.
Welcome, sir.
Yep. Bye bye. Good night.
Without any delay, I request Dr. N. Balaji sir introduce our next speaker, Dr. N. Milton Ganesh sir. Sir, please.
Wait a minute, ma'am. Yes. Okay. It's my great honor and privilege to welcome Dr. S. Milton Ganesh. He is an experienced academic and researcher in computer science and engineering with a PhD in information and communication engineering from Anna University. He is currently the assistant professor and head in charge of the IT department at the University College of Engineering, Dindivanam. His expertise spans cloud security, network security, and vehicular adapt networks with over 2 decades of experience. He has guided numerous research projects, published widely, and contributed to software development. He has also delivered guest lectures, attended faculty programs, and held administrative roles. I am welcome you, sir. I kindly request you to take over the session, sir.
Balaji sir, good evening.
Good evening, sir.
Yeah, can you hear me and can you see
Welcome
the
you, sir.
presentation, sir?
Yes,
Thank you very much,
sir.
sir.
You can start.
Yeah.
Sir, you can start, sir.
Yes, sir. First of all, I would like to thank Balaji sir and Ondal madam for painstakingly arranging this Atal FTP. I know that organizing a physical FTP itself is very a daunting task, but a person like Balaji sir and Ondal madam, I know you have you should have put in, and you would have put in so much of hard work. For I think you have been arranging this work for more than 1.5 months and arranging the guests and scheduling the sessions. So at this juncture, with more than 150 participants, I think this session is going very well. And also, I feel very much elated and happy to be part of this wonderful FDP. As a resource person, I would like to touch upon the topics related to Kubernetes, storage, and configurations. So before delving deep into the theoretical concepts of Kubernetes storage and configurations, I kindly request the audience to permit me to discuss about the basics of software development lifecycle and the evolution of containers with its support for DevOps and the need for Kubernetes, and finally the importance of storage and its configuration in Kubernetes. As a student, everyone who has learned about computer science would have come to know about software engineering. So when we talk about software engineering, people think that software engineering is all about the people who code alone. But behind the scenes, once the software is created and it is moved to the server where it is available to the clients, that kind of server, we call it as the environment called production environment. But people, the layman, or the students who are studying engineering or bachelor's degree in other disciplines, they are not aware of the work done by the people who maintain the software after it has been deployed to production. The real issue nowadays, people and that means the end users and the clients, the business service providers themselves are facing is with the maintenance of production environment. Nowadays, there are so many software tools to develop code, but it has become very, very tough to maintain the software in the production environment. Here, the software development lifecycle, yeah, actually in our curriculum, we would have learned about software engineering. It's a kind of workflow which consists of requirements gathering by going directly to the client environment, sitting with the client, understanding the needs of the client, understanding the business needs of the client, and noting down everything. Finally, we do a software requirement specification. Then we go for designing it. There would be a experienced coding team who would have been doing the designing work. Basically, they will do designing work. In 1980s and 1990s, they started doing object-oriented analysis and design kind of thing. After that, they would go for development. Maybe it is top-down approach or bottom-up approach, as we see in object-oriented programming. So after the development, the code is deployed. So the code is deployed and it would be maintained by the people in the production. What am I talking to you is in 1980s and 1990s, where the concept of cloud was not available, where the concept of on-premises, very big kind of storage servers were not available. That means it was available only with very big software companies. After the software is moved to the production, it would be managed or it would be supported for any errors. Actually, support would be for 24 bar base support. Actually, this thing is what is called as the phases of software engineering. Here, the software engineering can be done through different models, like waterfall model, where requirements gathering would be stopped at a particular stage. After then, software developers did go for developing the design. Once the design was over, the phase of coding started. After that, testing would be started. Finally, the code would be released to the client. Different kinds of support would be provided. One kind of support is on-site support. Another kind of support is offshore support through on-calls, phone calls, and raising the tickets. This was with software engineering. Nowadays, there has become a different kind of workflow which the software industry itself is moving to. Nowadays, you can see that a student who graduates engineering or any other computer science course is not expected only to develop code. A student who has passed the degree and he is looking for a software engineering job or a coding job, he should have knowledge in front-end code development. It includes UI, UX design if it is a web-based application. He also has to code, maybe using pure HTML code or React code or React code or Angular code if we are talking about a single page web application. He should also know how to write APIs where the business logic themselves are being run in the back end. The actual business is run in the business logic servers. It is in the middle layer. The business usually the clients access only front end. Now a software engineer has to develop front end, and also he should know about developing APIs in the middle layer. Also, the same HTML developer or React JS developer or Angular front-end UI UX designer should also need to aware of the back-end database servers also. This is what we call as full stack web development, full stack Java development, full stack .NET framework development. In .NET framework also we have got Windows based applications, and also we have got web based applications. Nowadays, a software graduate who graduates from the college needs to be aware of all these three things: front end, managing and writing APIs, and you should also have the knowledge of database. This is one part. This is one part only. Apart from this, in the next 2 to 3 years, it is not about if, it is only about when. The topic, which is what we're discussing now, is about DevOps. Developing, moving, and managing the entire software application in the cloud. Actually, what we are discussing is all about not SaaS, software SaaS. It's all about PaaS, PaaS. Software as a service means the whole application itself would be provided by the cloud service providers. For example, Gmail, we need not do anything. We just pay the fees through our international debit card. We get different number of emails for our office. If we want any other service like the storage space, increase in storage space or decrease in storage space, if we want our domain name, if we want different kinds of security or for different kinds of protocol, we can define it accordingly. If we pay, we get the service. This is SaaS. But what this FDP is about, DevOps is not about SaaS. It is about PaaS. PaaS means platform as a service. Platform as a service means the application is not provided from the cloud storage service provider. The application is actually developed in the on-premises. On-premises means when you are working in a TCS office, your project manager, your team leader, your group leader will go on site for some time, and he will sit in on calls in the offshore at some time. He will get the business requirements. Accordingly, he will make a plan for when to release which part of the software. This is sometimes when I was working in a project, they call it as time box. They would get the requirements once every month. They would move a small part of software coding to production. So time box 1 means a small part of software would be moved to production. In the time box 2, maybe it is next month or 1.5 months or 3 months, depending on the effort. It is planned already. So next part would be moved to production. This is how it goes. This is what is called as PaaS. Now, here I am talking to you about software development lifecycle. It is not about software engineering model. It is a software development lifecycle. In the next 3 to 4 years or next 2 years, graduates who are passing your degree should have knowledge about cloud native operations. In cloud native application development, we have different kinds of technologies for business workflow, like DevOps, like security ops, like platform ops, like performance ops. Different ops are available. DevOps is something which integrates software development and also the maintenance of the application in the production system. Usually nowadays the production servers are rarely offshore. Offshore means in the TCS office or Infosys office. Mostly the production environment is only with the cloud service provider. If the project is a very big project, like maintaining the other data, like providing DigiLocker facility, now the government, even the you know that every business and the government is moving each and every application
Dear participants, wait for a few minutes. Sorry for your inconvenience. We have an important update for you all. And I request all the participants to give the Atal a registered mail ID to join the session as well as fill the feedback form also. So kindly rename your Gmeet ID with your college name and your name. You can use the short form of your college name also. So if you attend both session alone, you will be marked as present. So both the Gmeet and feedback link address will be considered. Attend the both sessions. 80% of attendance is mandatory for a certificate. So kindly attend both sessions.
Dear participants, kindly wait for some time. Our resource person, now he is in Oman, Muscat. So that I think he is having network issues. So kindly wait for some time. Thank you. வேணும் பண்றோம்.
we also have another role, role 2, which has been granted privilege C. In addition to that, role 1 is granted to role 2, and finally role 2 is granted to user 1.
So hi all, Ravi here. So if you have any questions, I've just joined again. Okay. If you have any question, you can just put that in the chat. Okay. And I'll be able to answer that. Okay. Is it working now? Everyone is able to hear?
Yes, sir.
Yep,
You're
sure.
audible.
Yep, sure. Thank you. So probably we'll take a quick quiz with respect to the Kubernetes and storage. Okay, just to have some. Let me just put few questions. Okay, so this will be you can just follow a rapid fire round over here. Okay, let me put the question, and you are going to give the answer. Okay, so the first question goes like this: What is Kubernetes? A container runtime, a container orchestration platform, programming language, or database management tool? B, 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 B. Okay, right. Okay, this is pretty simple question. Okay. Um. Okay. So we go a bit. Uh. Yes, everyone know that. Okay. Now next question is this. Which component in the Kubernetes is responsible for managing the pods? Managing the pods. Kubelet, kubeproxy, etcd, containerd. BAA, BA, 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 BA. Okay. A. So those who are given A is the correct answer. Okay. So it is a kubelet. Okay. The answer A is correct. Right. Next question goes like this. I'm not sure if you are. Okay. So this is what we have also covered it. But let's see how many of you remember that. Which command is used to create the namespace? Okay. So kubectl is the same. Create is also correct for the namespace. B. That's correct answer. Right. Um. Okay. So I'm not sure if you know about this. Okay. Let me do that again. Right. So this is again one more question which is coming to yes B. Okay. The next question goes like this. What is the function of Kubernetes deployment? C. Right. So C is the correct answer to manage the lifecycle pods and ensure the desired number of replicas. Right. We have done that. Right. Okay. On the top of it again, the question to it is this. That is correct. Now, next question we are going to is what does Kubernetes replica set do? Manages pod scheduling, ensure number of specific pod replicas. B. Okay, good. Okay, let me put some hard questions to you. Let me put some right. Now, this is something you you learned about it, but I'm not sure if you know about this. Which is the default type of Kubernetes service? Cluster IP, node port, load balancer, or external link? Okay, a logical question. Okay, all are Kubernetes services only, but which one is the default one? DC, DC. External load balancer by default. DCA. So by default it is cluster IP. By default it is cluster IP. That is A is the answer. Okay. So there is no load balancer by default. Load balancer you have to create it. See logically you have to understand. Node port you have to define it. Okay. Load balancer you have to create it. DNS that is external name. That is DNS routing you have to do it. What is there as a permanent part? That is cluster IP. So by default cluster IP will be the default service. Okay. What is? I'm not sure to know about this. What is the default? If you are now having a default storage class in Kubernetes, I'm not sure if you know about it. But let me just put presentation. I think ma'am and sir, Dean sir will be able to share it with you at the end of the session. Okay. So what is the default storage class? A. What is A? What is A over here? No, the answer is B. The answer is B. So standard is a default storage class. So it is not default, but it is a standard one. Okay. Let me just put something interesting. Sorry. So let's go ahead and let's understand this. Okay. The next question is this. What is storage class in Kubernetes? What is storage class? A class considering network policies, a class used to define the storage policies, class used for pod scheduling, or class used for service discovery. All right. So you can remember it in a very simple way, right? It defines the storage policies. Okay. Just like we have 1 star, 2 star, 3 star, 5 star hotels, right? Accordingly, we'll have a different class for that hotels. In the same way, we have a storage classes. Okay. So what we do in the storage class, we define the storage policies. Okay. So when I'm saying when I'm defining storage policies, what kind of files or folders or how I'm going to store that, that is what I'm going to define in the storage class. Okay. So it is basically a class used to define. Answer is B. Class used to define storage policies. Right. Hmm. Let me just put another question. This is again a concept in Kubernetes. Okay, might be covered, might not be covered. I'm not sure. But what is daemon set in Kubernetes? Okay, so remember that daemon set is nothing but it is a daemon. So do you see the daemon? No, you don't see the daemon, right? So basically, it is a set of pod that ensure one pod runs in the background in each node. Now see, each node they are talking, right? One pod running in each node. Okay, one pod running in each node. That means every node will have that pod running. That's why it is called as daemon, running in the background. So we don't see the daemon. Daemon is always there, but we don't see. That means a pod, daemon set is a pod which is running in the background, like a system process, of course. Okay. Which command is used to scale the deployment in Kubernetes? Which command? Yeah, daemon. Yes. I'm not sure if you have heard about zombie processes also. So there is something called a zombie process in Linux. If you're interested, you can learn about it. Okay. So which command you used to scale the deployment in Kubernetes? Scale the deployment, resize the deployment, increase the deployment, expand the deployment. Yeah, of course, it's a A. So it is to scale the deployment. All right. Hmm. Okay. Hmm. What is Kubernetes in Grace? In Grace. What is Kubernetes in Grace? A type of pod, a set of rules that expose services outside the cluster, a type of config map, or an interrupt policy. What is in Grace? Um, So basically, the ingress and outgress are the two are outgress are there. See, basically, when you talk about ingress and outgress, generally those are related to the routing. Okay. Now I have a routing in terms of two ways. Okay. First in terms of the port, second in terms of my services. Okay. So what I need to do is, let's say that you went to someone's home. Okay. But then you need okay, you went to a particular your friend's home for the first time, so you need someone to navigate you to a particular location. Let's say that you want to go to kitchen, you have to go to hall, you have to go to gallery. Okay, so you need that friend who know everything about it, right? So that is how we say ingress. So somebody is coming inside your home, so how he or she will be routed, that is ingress. Okay, but let's say that you're going to go some to some beach location or to some mountain, okay, from your home to outside. Okay, so there will be some guide, okay, will be telling you that how to go. That is outgrace. That is called as outgrace. So what is coming inside is ingress. What is going outside is outgrace. Ingress with respect to Kubernetes is a pod which is defined, okay, which is nothing but a nginx, and in the nginx we define the rule that if the request is coming to our Kubernetes, how and where it will be navigated. So you can define that. Let's say if request is coming from for a ABC application, okay, route it to the node port 32440. If request is coming for this XYZ application, route it to the load balancer of XYZ application and it will get routed. Okay, accordingly, right? So answer is B. It is about the rules. What is the purpose of Kubernetes job? Okay, so these are basically the controllers. If you want to learn more about it, no, you can learn more about it with the controllers also. Okay, these are basically about the Kubernetes controllers. Kubernetes job, okay, as simple as that. Okay, if you have heard about the cron job, in Kubernetes, it is the same thing. Yes, but to manage the configuration data, no, that is wrong. B is the answer to it. Okay, to ensure the execution of the task to completion. So it is as simple as that. Your cron job is there. Okay, you execute it and you close that. Okay, so pod will be up and running. That will get executed. The task will be executed, and then pod will die or it will go down. Okay, for example, let's say you have a payroll running on every 30th. Okay, every 30th of the month. So every 30th of the month, this job will be created in the Kubernetes. That means a pod will be created in Kubernetes. Inside that pod, this application is there, which is going to process your payroll. The application will be executing your payroll, and then the pod will go down. As simple as that. So such kind of pods where a task is executed, okay, that is called as job in Kubernetes. So those are called as Kubernetes job. This is one of the controllers. Okay. Now maybe I'll going to give you the last question to you. Which command is going to give it to the persistent volume? Okay. Which command is used to delete the persistent volume? Remove, delete, get, create. It's delete. Okay. So probably, yeah. So here onwards, I think the other person will take it. Okay. Uh, with the further updates. Okay. So thanks all then. We'll continue our session tomorrow. Thank you. Have a good day. Bye bye.
Thank you, sir.
Yeah.
Itu dah gila. Dear participants, I apologize to everyone. Due to technical problem, our resource person, Dr. Mr. Ganeshan, is not taking the session. I think he is having network issue. Right now, he is in Muscat. He is attending today conference. So that I will arrange this session 4 in upcoming days. So I will post in the group. So I apologize to everyone. We'll take the session on upcoming days. Okay. I will share the details tomorrow or day after tomorrow. I will share the details to you. Okay. Thank you for attending, all the participants.
Dear
Ma'am,
participants, day 1 and day 2 feedback links shared in the chat box. Kindly check out and kindly fill out the forms immediately. Thank you all. Looking forward to welcome you all tomorrow with the same enthusiasm. Thank you all. Abhirami ma'am, kindly share the feedback link.
நல்லா இருக்கும். அதான் போன வாரத்துல இப்போ சொன்ன சரி. இதே நம்பர் தானே? அதான் சரி சரி சரி. அப்புறம் அவங்க அக்கௌண்ட் நான் போய் போட்டு வச்சுட்டு
Thank you for all the participants. Thanks for your support. Andal ma'am, Pavitra ma'am.
Sir,
Next என்ன proceed பண்ணிடுங்க.
okay, sir. Thank you for all participants. Upcoming sessions, we will update you tomorrow. Thank you all. Now you can leave the session.
Sir, the session is over. I request all the participants to kindly leave the meeting. Tomorrow we have to share the schedule in the WhatsApp group.